Assalamualaikum to Dr. Abdul Kadir. Today, me and my friends are going to present about our project, which is credit scoring in the global financial world and how we predict an individual credit score. My name is Nur Aina, CD20117, and I'm going to present about the first part in our project. In global financial world, credit scoring is a common method for assessing how trustworthy and reliable a person is with money. A credit score shown as a number sum up someone's credit history, financial habits, and repayment behavior. The standard score usually ranging from 300 to 850 is important in many countries, including Malaysia. Around the world, banks and leaders use credit score to decide how risky it is to lend money to someone. Credit score affect loan approval, interest rates, and credit limits everywhere. A higher credit score often means better loan terms, while a lower score can make it harder to get credit. This global practice shows a shared goal of responsible leading and financial stability through credit scoring. Several factors are key to accurately calculating a credit score. One important factor is income, which is the money a person earns over a certain period, usually from jobs or business activity. Other important factors include education, material status, number of children, and home ownership. These factors help determine if credit score is low, average, or high. The objective for our project are first to predict individual credit score using dataset attributes. Second is to achieve reliable prediction with at least 70% accuracy in determining individual credit scores. The last one is to display the prediction data using fuzzy membership functions and fuzzy rules. Here are the input and output attributes used in our analysis. The first one is age, gender, income, educations, material status, number of children, home ownership, and credit scores. We use dataset contain of 165 samples of people credit score from around the world. Here is an example of dataset we acquired from the Kaggle.com. Our neutral network framework begins by identifying crucial input variables: income, education level, number of children, and homeowner status. These variables are initially transformed into numerical values and then normalized to ensure that they are on the comparable scales. Moving forward, we design a neutral network architecture with an input layer that incorporates these normalized variables. This setup is followed by one or more hidden layer, which process to extract meaningful patterns from the input data. The output layer is configured with nodes representing credit score, categories, low, average, and high. To ensure the reliability of our model, we split our dataset into three subsets: training, validation, and testing. Training, validation, and testing. The training phase involved optimizing the neutral network using appropriate loss function and optimizer. Through iterative training, our model learns to accurately map input variables to their respective credit score categories. Following training, we evaluate our model's performance on the test dataset using key metrics such as accuracy. Our trained neutral network can be leveraged to predict credit score for new data inputs, thus aiding in informed decision-making process. For the hyperparameter settings, hyperparameters are critical settings that influence how our neutral network learns from the data. In our study, we focus on three primary hypermeter: learning rate, epoch, and batch size. For the set 1, we have two sets. For the set 1, learning rate, the learning rate controls the speed at which our model adapts to the data. In our initial setup, the optimizer used a default learning rate of 0.001. For the epoch, we conduct training over that epoch, allowing our model to iteratively refine its predictive capabilities across the entire data set. For the batch size of 10, our model processed 10 training examples in each iteration, balancing computational efficiency and training accuracy. For the set 2, for the learning rate, to explore the potential improvement, we reduce the learning rate to 0.001. This adjustment tests whether smaller step enhance to our model's accuracy over time. For the epoch, we also evaluate the impact of fewer training iteration by reducing the number of epoch to 50. This approach assesses whether a shorter training period can still yield satisfactory result. For the batch size, we increase the batch size to 32, aiming to expedite the training process without compromising model performance. In conclusion, our studies underscore the significance of methodological approach and hyperparameter optimization in neutral network modeling. For credit score prediction, by carefully selecting and fine-tuning these parameters, we aim to enhance the accuracy and efficiency of our predictive model. That's all from me. I will pass to my partner. Thank you.
Hi, Assalamualaikum. My name is Nur Abiha binti Kamarul Zaman. My mission number is CB20042, and I am the second presenter in this project, which is the neural network project. For the result, there is two set of result, which is the first set, we use the epoch 10 and the batch size is 10, and then the second set we use the epoch 5 and the batch size is 1. So this is the table of data set. This is the data set, and then I will show you the coding, the Python code for this neural network. So this is the Python code. Which is I use the this is the Python code, which is I import the pandas as PD, and from a scalar model selection, import trend test split, and this is the df, which is we define the PD dot read underscore CSV. CSV is the data set. So and then second is the data. The data we use is gender, education, marital status, home ownership, and credit score. So this is the data that we implement in the our data set. So the mapping gender, we have male, female, education, high school, bachelor, master, and PhD. Status, single and married. Home ownership, owned and rented. Credit score, low, average, and high. So this is the coding for the mapping gender, mapping for all the data frame. So in this, next, we have this one, credit score, standard scalar, and then we import to the categorical, and then this is the, okay, so this is the example, the result of, for example, first set 1, and this is the result for example set 2 for this. So the conclusion is, in this project, we have focused on research the credit score classification data set by use the neural network state system. So this is the our project that we use with an ANN method. To achieve this, we have designed hyperparameter for the attribute. And then overall, this project highlighted the effectiveness of neural network in manage complex and uncertain data. So we have done, and this is the reference that we use, and this is the Python source code. So I have screenshot the Python source code and already implement in the project, in the report of the project. So that's all from us. Thank you, sir, for giving us the opportunity in contribute the project. So I hope we hope that we get the best result at the end. So thank you for watching, and Assalamualaikum.